This is a fun one. In this video, I'm going to go over an alternate form of the derivative. In this formula, it's a lot faster than the first one we used, but the catch is it doesn't always work. Let me show you. Here's our formula. F prime of c equals the limit as x approaches c of f of x minus f of c, all divided by x minus c. Now something to note about this. C is a constant, so this only works when we're looking for the derivative at a specific point. And also, there's some algebra that has to work kind of down the line, so I really wouldn't use this formula unless you're specifically told to, because unless the problems are made in a kind of a really specific way, the formula's not going to really help you out that much, and you have to go back to the really long version. But if you're told to use it, you can get really excited because it's fast and it's easy. So just know that it's used when you're looking for the derivative at a specific point, and the formula will not always work. So if you get stuck, that's okay, right? You can always go back to the old formula. Let's do an example. Find f prime of 3 when f of x equals 2x plus 4. First, we write down our formula. The limit as x approaches c of f of x minus f of c, all divided by x minus c. Okay, so what do we need for this formula? Well, we know that c is 3. We were given f of x, that's 2x plus 4. And now we need f of c, so f of 3 equals 2 times 3 plus 4, or 10. And now we just plug everything in. F prime of 3 equals the limit as x approaches 3 of f of x, 2x plus 4, minus f of c, 10, all divided by x minus c, or x minus 3. All right, so we simplify that bad boy, and we get the limit as x approaches 3 of 2x minus 6 divided by x minus 3. Okay, this is a limit. We know how to solve limits. We plug in 3, we get 0 over 0. Oh no, that doesn't work. What do? We go to cancellation. Is there a common factor here? Well, let's hope that x minus 3 cancels, and it turns out it does. This simplifies to 2 times x minus 3 divided by x minus 3. We factor out the x minus 3 and it cancels, and we're left with the limit as x approaches 3 of 2. And now we remember from our limit properties that the limit as x approaches 3 of 2 is just 2. So f prime of 3 equals 2. And we're done. Wasn't that so much easier than the full definition of the derivative? I think so. Let's review what we did though. We said, okay, limit as x approaches c of f of x minus f of c, all divided by x minus c. We can use this formula because we're looking for the derivative at a specific point at x equals 3. Okay, so c is our 3. So what is f of c? We found that. We know what c is. Again, it's 3. And we just plugged everything in, solved the limit, and did the cancellation, and then we were done. That was it. And in these problems, just as a note, in these problems, you're going to see the cancellation method a lot. A lot. Let's do one more example. Find the equation of the tangent line to y equals x squared plus 2x at x equals 1. Wait a second, we've only been dealing with f of x. What about y? Is there a difference between y and f of x? No, there isn't. Just pretend the y is an f of x. It'll be fine. It works. They're basically the same thing. I don't know why math does that, but whatever. Also, equation of the tangent line. We did something like this before, right? We did something like this in one of our previous videos. So let's figure out what we need. So our point slope formula, y minus y1 equals m times x minus x1 in parentheses. We know that m is our slope, and that's going to be f prime of 1. And x1 comma y1 is any point on the tangent line. So let's go ahead and find m first. We're looking for f prime of 1, so we're going to try our alternate form of the derivative. We're looking for the derivative at a specific point. So the limit as x approaches c of f of x minus f of c, all divided by x minus c. What do we need? We know that c equals 1, so we've gotten that. We know that f of x equals x squared plus 2x, so we've got that. Now we just need f of c, so f of 1, so we just plug 1 in, and we get 1 squared plus 2 times 1, so f of c is 3. Now we take those components and we plug it back into our formula. F prime of 1 equals the limit as x approaches 1 of f of x, which is x squared plus 2x, minus c, so minus 3, all divided by x minus c, or x minus 1. Okay, so again, this is a limit. How do we solve it? Try plugging in 1, we're going to get a 0 over 0, which that's no good. So can we use cancellation, right? That's our plan B. And it turns out we can. That numerator factors into x plus 3 times x minus 1. And so we have that divided by x minus 1. Our x minus 1's cancel. And we're left with f prime of 1 equals the limit as x approaches 1 of x plus 3, which we can just plug 1 right in, and we get 4. So that means that our slope m equals 4. So we have the slope, and we still need that x1, y1 point. I explained this in one of my previous videos, but it's a problem you'll see time and time again, so I think it's worth going over again. How do we get the x1, y1 on our tangent line? Well, we know our tangent line intersects our function at one point. So that means that our function and our tangent line share an x1, y1. And we know that by definition, since we're finding the tangent line at x equals 1, the tangent line and the function share a point at x equals 1. So we can use our x value, plug it into our f of x, not our f prime of x, plug it into our f of x to get our y1. And that point will be on both the function and the tangent line. So let's do that. So x1 equals 1, y1 equals, we plug in 1 squared plus 2 times 1, so y1 equals 3. And then we can just write out our point slope formula. We have everything now, right? Y minus 3 equals 4 times x minus 1 in parentheses. Again, most teachers will be fine with you leaving it in point slope form, but in case they're not, just for completeness sake, y equals 4x minus 1. That is our tangent line. All right, that is all I have for the alternate form of the derivative. It's really not too bad, is it? The problems are quick, and the algebra is not nearly as complicated as what we saw before. It's kind of a smaller unit in calculus, but it's still good to know. The only catch with the alternate form, as we discussed earlier, is that you have to be finding the derivative at a specific point, right, at a c, and the algebra has to work out, right? As we kind of saw, you need that denominator to cancel. If it doesn't, you're kind of in trouble. So really, you kind of only want to do this when you're specifically told to, but when you are told to, get excited because it's easy and it's fast. So these problems should be absolute gimmes on a test. If you found this video helpful or if you enjoyed it, leave a like, subscribe, and I'll keep the math content coming your way.